Welcome to this video, where you'll learn about Chroma vector database concepts and architecture. After watching this video, you will be able to explain the purposes of large language models, summarize the limitations of large language models, describe how Chroma DB manages the large language model limitations, explain Chroma DB architecture. Large language models, LLMs, are a type of artificial intelligence, AI, that are very good at reading and writing text that sounds like a person wrote the text. LLMs use deep learning methods to evaluate and process large amounts of text data. LLMs can perform tasks such as creating new text, for example, writing unique content of different types and emails, summarizing text, such as shortening long stories or writing executive or technical abstracts. Answering questions happens when you ask an LLM interface a question to obtain helpful answers to your questions. Obtaining machine translations, which change words from one language to another. While LLMs perform many functions, they can also encounter some limitations. Informational biases, information inaccuracy, and difficulty understanding basic data are some limitations that can occur with large language models. First, let's examine informational bias. LLMs learn from the text they can access, usually internet-sourced text. The process is the same as how a robot learns from conversations. If those conversations contain unfair or biased text, the robot can incorporate those biases as information. Similarly, LLMs can learn biased information from the internet, which means that the LLM might deliver biased answers. LLMs are advanced tools for verifying and processing information, but are not infallible. These models can interpret extensive data, yet there are instances when inaccuracies can occur. These inaccuracies are particularly noticeable in subjects outside the LLM's primary knowledge base. Consequently, while LLMs provide valuable insights, LLM users need to acknowledge that the responses by the LLM might not always be accurate, especially for topics where the LLM has limited exposure or information. LLMs can struggle with basic facts that humans take for granted, so if you ask the LLM a question that requires a basic understanding of day-to-day facts, the LLM might give you strange, unexpected answers because the LLM doesn't have that basic knowledge. LLMs can only learn and train themselves from the data they receive. Many LLMs learn from internet data, but a lack of data can create problems if the data is limited. For example, due to a lack of data, an LLM might produce inaccurate conclusions based on the following assumptions. First, you can hold a spoon in your hand. Second, you can write on paper by holding a pen in your hand. Based on this information, the LLM might deduce that you can use a spoon to write on paper. Vector databases play a vital role in resolving these misunderstandings. A Chroma vector database is a suitable solution for resolving these issues. A pen and a spoon are data objects. As such, data objects within a vector database exist as vectors, which are like lines or points in multiple dimensional space. The vector database describes each feature of each data object using a dimension. The database stores a number for each dimension. When comparing two data objects, the database views the dimensions' numbers. The database calculates the distance between the dimensions that represent the data object's features to determine the closeness or similarity of the object. Next, reconsider the example of the spoon and the pen. In this example, the first sentence says that you can hold a spoon in your hand, which suggests that a spoon is something that you can move or hold. The second sentence says that you can write on paper by having a pen in your hand. This sentence suggests to the LLM that a pen is an object a person can hold and move in their hand. However, based on the first sentence, the LLM will also conclude that a person can use a spoon to write on paper. To show the features of a spoon and pen in a vector database, you can assign dimensional measurements that represent characteristics for the item's shape, material, function, and so on. You would probably find that the vectors representing a spoon and pen are very different for the function dimension. You'll identify the function of a pen is for writing, and you'll identify that a spoon's function is for eating. Then, when you run the task to compare the vectors representing the spoon and pen, The vector database contains the information to distinguish that their function dimensions are different. Using the vector database, you can conclude that you cannot use a spoon to write on paper. In summary, you can use the vector object's dimensions to identify characteristics that result in similarities and differences. Using a vector database solved all three limitations an LLM cannot easily resolve independently. Let's review how using Chroma DB resolved these limitations. First, vector databases can help reduce informational bias. By incorporating diverse data sources and representations into Chroma DB, you can train LLMs using a more balanced foundation, mitigating bias. Next, you can use vector databases, including Chroma DB, to enhance information accuracy. You can use a vector database's ability, including Chroma DB's ability, to store and query factual knowledge graphs into LLMs to improve the accuracy and reliability of the generated text. Finally, Chroma DB improves the understanding of basic data. You can encode common sense knowledge and relationships within Chroma DB to supplement LLM training, leading to more relevant answers. Next, check out Chroma's vector database architecture. Chroma vector database architecture works in multiple phases. During the first phase, you'll obtain embeddings. During this phase, you'll convert text, images, or data into numerical formats, which are vector representations. Next, you'll create collections. Similar to tables in a relational database, Chroma DB creates collections. Then, you'll store vector information within the collections. After pre-processing and turning the data into vectors, the database stores information in collections, including text and embeddings. Now, it's time to perform collection operations. Chroma DB lets you perform tasks including deleting, updating, or renaming your collections, giving you more options for organizing your data. Finally, you'll query and group data for the most useful information. Chroma DB lets users use text or vector queries to find information in groups based on semantic meaning or similarity. In this video, you'll learn that informational biases, information inaccuracy, and hurdles in understanding basic data are limitations that can occur with large language models. In Chroma DB, you can use the vector object's dimensions to identify characteristics that result in similarities and differences. Chroma DB architecture progressively applies the following phases: obtain embeddings, create collections, store information within the collections, apply collection operations, and query and group data.